So we've identified what resources our Earth gives to us and that we have a limited amount of resources. And we talked about that phrase sustainable development, which is being mindful about how humans use the resources. We gotta do what we gotta do for our population, but let's keep other populations in mind as well. First of all, let's look at soil. Topsoil is the mineral and nutrient-rich part of the soil, just like it sounds, on the top. It absorbs and retains moisture, but allows water to drain. It's rich in organic matter and nutrients, but low in salts. Good topsoil is produced by interactions between the soil and the plants growing in it. It can be renewable if it's managed properly, but it can be damaged or lost. Poorly managed farming and drought in the 1930s in the plains led to the Dust Bowl. So what happened was farmers converted prairie to cropland, and the soil was vulnerable to erosion. Erosion is worse when land is plowed and left barren between plantings. When there's no roots, it's easily washed away. Organic matter and materials that make it fertile are often carried away with the soil. In the areas of dry climates in the world, farming, overgrazing, drought, and climate change can turn farmland into desert, and that's called desertification. 40% of Earth's land is at risk for desertification. And you can see in this map, specifically in North America, which areas are at risk. A lot in the western United States. Then we have deforestation, loss of forests. The old growth forests that had never been cut, about half of them have been lost to deforestation. Healthy forests hold the soil in place, they protect the quality of fresh water supplies, they absorb carbon dioxide, which is good to offset what we put in by our actions, and they help with the climate. In some areas, forests can regrow after cutting, but it takes centuries. We talked about succession last couple chapters. It takes centuries, as you've seen, for succession to get it back to the way it was. In some places, for whatever reason, forests don't grow back at all after logging. That's why old growth forests are usually considered non-renewable resources. Even though I said that trees are considered renewable, those old growth forests are considered non-renewable. Deforestation can lead to severe erosion. Grazing or plowing after it can permanently change local soils and microclimates, and it can prevent the regrowth. When tropical rainforests are cleared for timber or for agriculture, they don't have the best soil, so their soil is typically useful for just a few years. And after that, they become a wasteland. The topsoil, like I said, isn't the best, and the high heat and humidity prevent regrowth. So some things we can do: sustainable use, sustainable development. Leaving stems and roots of the previous year's crop in the soil can help hold soil in place between plantings. Crop rotation, I mentioned, planting different crops at different seasons or in different years, can prevent erosion and nutrient loss. Contour plowing, planting fields of crops across instead of down the slope of the land. It can reduce water runoff and therefore erosion. And then terracing, shaping the land a hilly land to create level steps, also helps hold water and soil. Selectively harvesting mature trees can promote the growth of younger trees. It lets the sun through for those younger trees and preserve the forest ecosystem. So instead of just slashing and burning and cutting down every single large tree or mature tree, just do some of them, everything in moderation. A well-managed tree farm protects the soil and makes the trees themselves renewable. Let's move on to water. Obviously, fresh water is a good and a service. Drinking water, industry, transportation, energy, waste disposal. Farmland relies on irrigation. Some sources of fresh water are not renewable. We said today that fresh water is a renewable resource, but some are not. The Ogallala Aquifer, it's an underground water source, goes from South Dakota all the way down to Texas. It took more than 1 million years to collect and is not replenished by rainfall. So much water is being pumped out, it's expected to run dry in 20 to 40 years because that water supply is servicing all of those states. Interesting and scary statistic, only 3% of the Earth's water is fresh water, and most of that is locked in ice at the poles. A pollutant is something that's harmful that can enter the biosphere. Freshwater sources can be polluted. A factory or an oil spill can cause pollution from a single source. It's called point source pollution. It enters at one point. Pollutants that enter from many smaller sources, the grease and oil washed off streets, chemicals released by factories and automobiles, are called non-point source pollution. Pollutants can enter surface water and underground water that we access with wells. Primary sources of water pollution are industrial and agricultural chemicals, residential sewage, and non-point sources. One industrial pollutant is PCBs, organic chemicals that were used until the 1970s. PCBs are now banned. Unfortunately, because they enter mud and sand beneath bodies of water, they can be difficult or impossible to eliminate. So they might even still be around. Other harmful industrial pollutants include heavy metals like cadmium, lead, mercury, and zinc. Monoculture, because we're trying to grow only one type of plant, has increased use of pesticides and insecticides. These can enter the water supply in form of runoff after heavy rains, and they can seep directly also into groundwater. Pesticides can be dangerous pollutants. Pesticide called DDT controls agricultural pests and disease-causing mosquitoes. But they're pollutants. When DDT gets into the water supply, biological magnification can occur. So what happens is you have this chemical, DDT, mercury, or a PCB. It's picked up by an organism, not broken down or eliminated. It collects in body tissues. Primary producers pick up a pollutant from the environment. You see the ecological pyramid over here. We'll walk you through. The little orange dots are DDT, for instance. So the herbivores that eat those producers concentrate and store the compound. Because we have fewer numbers as you move up the pyramid and less biomass, the same amount of pollutant gets concentrated into fewer organisms and less biomass. So pollutant concentrations in the herbivores can be more than 10 times greater than that in producers. Then as we move up, the carnivores eat the herbivores, it's further concentrated. In the highest trophic levels, concentrations can reach 10 million times their concentration in the environment. So the organisms the most at risk are your top level consumers. This can cause serious problems. So widespread DDT use in the 50s threatened fish-eating birds, those top-level consumers. It messes with their eggs, the shell thickness of their eggs. That reduced hatching rates and caused a drop in bird populations. Since DDT was banned in the 70s, bird populations are now recovering. We still have mercury, which if you eat fish you've heard about, it accumulates in the bodies of certain marine fish, such as tuna and swordfish. It's to our advantage to be careful about how much fish we eat and know what fish sources our fish are coming from because of potential mercury poisoning. Sewage. This is a great topic. Sewage contains nitrogen and phosphorus. These are byproducts of waste. Sewage can stimulate blooms of bacteria and algae that rob water of oxygen. These are called dead zones, and they can go in both fresh and salt water. Sewage also contains microorganisms. Yucky. So how do we fix these problems? Protect the natural systems involved in the water cycle. Watershed conservation. A watershed includes all the land whose groundwater streams and rivers drain into the same place, such as a large lake or river. Pollution control can have positive effects on the water quality. Treating sewage can lower levels of the bacteria and prevent dead zones. Agriculture can use integrated pest management, so you can use predators and parasites to regulate instead of sprays, and then using less poisonous sprays, and crop rotation. Water conservation is also important. Drip irrigation delivers water drop by drop directly to the roots of the plants. Tiny holes in water hoses allow farmers to deliver water only where it's needed. Then let's turn to the air, the atmosphere. Ozone is a form of oxygen that's found naturally. It absorbs harmful UV radiation from the sun, so it's like a natural built-in sunscreen in our atmosphere. The ozone layer protects our skin from damage that can cause cancer. Greenhouse gases, carbon dioxide, methane, water vapor, help keep our temperature relatively stable. I think I've said this before. Without the greenhouse effect, the Earth's temperature would be about 30 degrees cooler than it is today. When we have air pollution, respiratory illnesses like asthma are made worse, skin diseases tend to increase. Climate patterns can be affected. Industrial processes, burning of fossil fuels can release pollutants of several kinds, including smog, acid rain, greenhouse gases, and particulates. Smog is a gray-brown haze formed by chemical reactants of pollutants that are released into the air by industry and by cars. Ozone is one product of these reactions. So ozone and other pollutants affect people with respiratory conditions. There was concern at the 2008 Summer Olympics in Beijing about how much smog there was in that city and how the athletes would be able to perform. Burning of fossil fuels releases nitrogen and sulfur into the air. When that combines with water, forms nitric and sulfuric acids. These acids can float as vapor for many kilometers before they fall back to the ground as acid rain. Acid precipitation can dissolve, release mercury and other toxic elements from soil. So it doesn't just do its damage, it can cause a chain reaction of more damage. Acid rain can kill plants, damage their leaves, change the chemistry of soils and water. It can also cause damage to human architecture, stone statues. If you see black smears on limestone faces of buildings or limestone details of buildings, it's due to acid rain. Burning fossil fuels in forests release stored carbon into the atmosphere as carbon dioxide. That's one of the greenhouse gases. Agricultural practices release methane, especially the keeping of lots of cattle, lots of livestock. That's another greenhouse gas. As we've said, some greenhouse gases are necessary to maintain Earth's temperature. But when there's excess greenhouse gas in the atmosphere, the question is whether it's causing our global warming to go faster than it would have without our intervention. Particulates, just like they sound, microscopic particles of ash and dust, again released by industry and certain kinds of diesel engines. Particulates can pass through the nose and mouth and enter the lungs, and these too can cause serious health problems. We have emission standards. If your car is over a certain age, you have to take an emissions test. Clean air regulations seem to be having a net positive effect as well. You can see the change on the next slide from 1980 to 2007, vehicle miles traveled, energy consumptions, and the emissions of 6 common pollutants. So what we see here, miles traveled is increasing, energy consumption relatively stable, pollutants have gone down. So that's a good thing. At one point, all gasoline was enriched with lead. Leaded gasoline was phased out in 1996 when it was banned. Unleaded gasoline has led to a decrease in lead levels in soils, rivers, and streams throughout the country.